Welcome back, everyone. If you're an aspiring academic, a grad student, or an early career researcher focusing on educational technology, you already know the path to a high-impact academic career can feel, well, a lot like a maze, right? I mean, where do you even focus your energy? Which tools should you actually master? Well, today, in this explainer, I'm going to put on my senior academic mentor hat, and we're going to deconstruct the ultimate case study, the incredibly robust publication record of Dr. Durga Raj Joshi. By tracking his trajectory, all the way from his foundational education straight through to the absolute cutting edge of artificial intelligence in mathematics pedagogy, we're going to extract a highly actionable blueprint, one that you can apply directly to your own research journey. So here's our syllabus for today's explainer. We're going to cover 1. The foundation. 2. Your analytical toolkit. 3. Leveraging PISA data. 4. The DEPSWILIC framework. And 5. The AI frontier. Let's get right into it. Section 1. The foundation. Building academic credibility. Look, before you can conduct these complex structural analyses or write global policy recommendations, you've got to put the time in to build a rock-solid academic foundation. You just cannot skip steps here. Taking a look at Dr. Joshi's actual academic milestones, we see a textbook example of steady, incredibly deliberate progression. So from 2005 to 2008, he completed his Master of Education in Mathematics Education at Tribhuvan University in Nepal. And notice that gap before his PhD, which he then pursued at Banaras Hindu University in India from 2014 to 2017. He didn't rush this journey. It was a highly calculated development of expertise in applied math and educational pedagogy. And that steady progression, that set the necessary foundation that allowed him to step right into faculty roles at Tribhuvan University and Nepal Open University in 2018. The big takeaway for you here? Don't rush those foundational years. The depth of your early training absolutely dictates the height of your future impact. Moving on to Section 2, the application. Mastering your analytical toolkit. Because, let's be honest, ideas are great, but in today's incredibly competitive publishing environment, you need the rigorous technical skills to actually back those ideas up. So the absolutely crucial point is this: you need an actionable checklist of software competencies. Dr. Joshi didn't just read about data analysis, he became a facilitator in these exact tools. For quantitative data analysis, proficiency in SPSS and JASP is practically non-negotiable if you want to publish empirical educational research. Doing qualitative work? You've got to know Atlas TI. And please, for the love of academia, use Mendeley or Zotero for your referencing. Do not do it manually unless you actively enjoy giving yourself a migraine. Master these tools and you literally remove the technical friction between your hypothesis and your final manuscript. Let's de-jargon one of the most important methods in his toolkit, structural equation modeling, or SEM. I know, it sounds super intimidating, but it's really just a multivariate statistical analysis technique. It lets researchers analyze complex structural relationships between observed variables and latent variables. Latent variables are basically just underlying traits we can't measure directly, like, say, student motivation. Dr. Joshi frequently executes this using the AMO software. And mastering SEM? That elevates your research big time because it lets you move way beyond simple correlations and actually test complex theoretical models about how different educational factors influence each other. Another highly sophisticated string to Dr. Joshi's methodological bow is item response theory, or IRT. Think of IRT like a massive, high-tech upgrade to how we evaluate educational tests. Instead of just looking at a student's total test score, IRT looks at how a student's underlying ability relates to their probability of answering a specific, individual test item correctly. Understanding these advanced paradigms is exactly what separates a standard, run-of-the-mill paper from a highly cited, authoritative piece of literature. Section 3. The application. Leveraging global PISA data. Okay, so now that you have the toolkit, you should know you don't always need to spend years gathering local data. Sometimes, the absolute most strategic move you can make is to leverage globally recognized datasets to generate timely literature. This is just incredible efficiency right here. Notice how Dr. Joshi took a single massive dataset, the Program for International Student Assessment, or PISA dataset, and used it to fuel multiple, distinct, highly cited research questions. In one paper, he looked at PISA 2022 to analyze how digital resources impact math achievement and self-efficacy. In another, he compared PISA 2018 and 2022 to investigate teacher efficacy and job satisfaction. He even used the dataset to evaluate the pandemic's impact on teacher competencies pre and post COVID. That is a masterclass in maximizing a single, robust data source. Now, I really want to emphasize the year 2022 for a second. Literally, the moment the PISA 2022 results became available, Dr. Joshi rapidly utilized them. By doing the analytical heavy lifting immediately, he successfully secured a whole slate of publications slated for 2024 and 2025, exploring how digital literacy and confidence shape math achievement across different economic contexts. Speed, when combined with rigorous analysis, is a massive advantage in academia. Which brings us to a critical transition point in your career. Analyzing data and publishing papers, that's the baseline. But I want to pose this direct question to you. How do you move from merely analyzing data to actually shaping pedagogy? How do you stop just observing the field and start actively guiding it? That takes us right into Section 4, the synthesis, building the Deep Silic framework. The answer to that question lies in synthesis. The true hallmark of a mature researcher is the ability to take years of disparate data points and synthesize them into structural frameworks that guide the entire educational sector. The creation of his 2021 Deep Silic Digital Competency Framework brilliantly illustrates that exact leap. See, he didn't just publish yet another paper on digital tools. Through a synthesis review, he codified the absolute essential digital skills required for teachers, spanning all the way from basic education up to the university level. This is an aspirational achievement. When you create a named framework, you're providing a common language and a standard for other researchers and policymakers to use. That is exactly how you cement your legacy in your field. Finally, Section 5, the frontier, embracing AI and machine learning. Let's see how all of this builds into the absolute necessity of career adaptability. You cannot just rest on past frameworks. You have to pivot toward the frontier of your discipline. And for educational technology today, that means artificial intelligence and machine learning. If you look at Dr. Joshi's earlier work, a lot of it examined traditional math learning, right? Like how teachers were showing resistance to mediating digital devices in pre-COVID classrooms. But contrast that with the modern reality he researches now. His focus has entirely adapted to modern integration. He's studying post-COVID digital resilience, the implementation of machine learning, and AI acceptance. A successful academic career isn't some static object. It is a constantly evolving response to the world around you. To prove this, just look at his slated 2026 publication, Role of Secondary School Students' AI Acceptance in Mathematics Learning in Shaping Academic Achievement. He is already publishing on the bleeding edge of how AI tools will integrate into applied mathematics for secondary students. Mastering new domains is exactly how you stay relevant. Seriously, if you are still only studying the tools of 2019, your research is already obsolete. We've unpacked a truly remarkable career trajectory today. We went from foundational education to mastering AMOS and SPSS, leveraging global PISA datasets, building original frameworks, and finally leaping right into AI. So I'm going to leave you with this provocative thought. What emerging tool, software, or dataset are you going to master next to build your own researcher's blueprint? The roadmap is right here in front of you. The next move is yours. Thanks for joining me on this explainer, and keep learning.